characteristics, how the VI characteristics of MOSFETs are drawn. Okay, the output characteristics of MOSFET, or it is also called as drain characteristics, and we have also seen the transfer characteristics of MOSFET. Now we have discussed the symbols of MOSFET also, and what is the value of drain current and drain current when MOSFET is in saturation region and it is in non-saturation region. So you understand the different regions on the MOSFET. We have already explained it. Okay. So let's have a short question answer session. Which region is called as saturation region? Please unmute yourself and let me know which region is called as saturation region. You answer today also, you can answer it the same fashion.
Where the
Come on,
current
quick.
is constant.
The region where current is constant when VDS is changing, but still current is constant. Okay, how this drain current ID changes with respect to VGS? Anyone? What is the effect of VGS on drain current ID? You can see the answer on this graph. What is the effect of VGS on drain current? Anyone? Please unmute. If VGS is increased, what will happen to ID? If VGS is decreased, what will happen to ID? The graph is there in front of you.
They are directly proportional to each other.
Directly proportional to each other. Okay. So when VGS is increased, ID is increased. You can see this relation on the transfer characteristics, as well as you can see on the output characteristics or the drain characteristics, that every curve where VGS is having greater value appears on the top of the previous curve. So VGS equal to 1 volt appears here, VGS equal to 2 appears above this. So if you go on increasing VGS, drain current ID will go on increasing. Fine, understood? Okay, what is the ohmic region? What is the relation between ID and VDS in ohmic region? Yes, yesterday you answered. Do it fast today, we have to cover a lot of things. Yes, what is the relation of ID and VDS in ohmic region? Yeah, please answer fast. Parth, what is the relation between ID and VDS in ohmic region? Parth Bhaviskar absent. Piyush, absent. Prathamesh Patel, the graph is there in front of you. Please answer. Rutuja, when I'm calling you by your name, you must unmute yourself and try to answer. Otherwise, I'll mark you absent. I will be noting the numbers of those students who are still not unmuting. Rutuja, Chetan Patel, Tejal.
There is linear increase in drain current with VGS.
I'm talking about ohmic region. Ohmic region. So for ohmic region, I want the relation between ID and VDS. On this axis, this is VDS. Yes. What is Ohm's law? Why it is called as ohmic region? Because it's following some Ohm's law, linear variation of current with respect to voltage. The voltage is varying linearly with respect to current. If you increase voltage, current is increasing. V is equal to IR. The voltage is directly proportional to the current. When V increases, current increases. All these things we have done yesterday. So this is ohmic region. Haven't you understood this?
Yes,
Please tell me first. Haven't you understood the three different region?
Understood,
Yes or
ma'am.
no? Then why don't you answer? There are three regions we have shown on the characteristics of MOSFET. The first region when VGS was less than threshold voltage, or either VGS is zero or it is less than threshold voltage, that time no current is flowing, and this region below this curve is called as cutoff region. Then when you go on, when you apply proper value of VGS, which is greater than threshold voltage, and then you keep on increasing VDS, you observe that current increases initially linearly, and then it reaches to maximum, and then it becomes to constant. So the region where current is increasing linearly is called as the ohmic region. And we have also studies that, let me annotate. We have also studied that this point from where, see this green color line we have plotted, so from this every point the drain current is essentially becoming constant, okay, and we call this voltage. So for this curve the voltage, I will call it as VDS sat. VDS sat, what does it means? After this point, or after this much value of VDS, the MOSFET is going into saturation. For this curve, I am calling this voltage as VDS sat, and after this it is going to saturation region. So I may say that when VDS applied drain to source voltage is greater than VDS sat voltage, then MOSFET goes to saturation. Clear? Okay. So VI characteristics of MOSFET we have done. Okay. So transfer characteristics as well as VI characteristics, these both we have completed for enhancement mode MOSFET. We have done completed with the symbols also. How you draw the symbols, I have shown this animation video, and we have written the two expressions for the current. When what is the drain current ID when MOSFET is in saturation region, and what is the value of drain current ID when MOSFET is in non-saturation region. So we have discussed these two equations yesterday. In detail, we will be explaining when we will solve the problems, yeah, or after this derivations. So ID, when the MOSFET is present in non-saturation region, which is also called as triode region, ID is this much. ID is equal to Kn into bracket 2 times VGS minus VT multiplied by VGS minus VDS square bracket completed. Here this Kn, we will write it as Kn or Kp depending upon the type of MOSFET. If MOSFET is of N channel type, we will write it as Kn. If it is P channel, we will write it as Kp. Similarly, VT, what is VT? What is VT stands for? What is VT stands for? Anushka? Anushka, what is VT stands
Threshold.
for? Threshold voltage. Very good. VT stands for threshold voltage. So if I am talking about N channel MOSFET, I may write it as VTN, or I'll be writing it as VTP if I am writing about, if I am doing about P channel MOSFET. Okay. Now, when the MOSFET is in saturation region, this is the current. And you have to remember both of these currents. So what is the current flowing through MOSFET when it is in saturation? ID is equal to K times VGS minus VTH bracket square. Remember, VGST is same as VT, because we write threshold voltage in terms of gate to source voltage. So either you write VGST or you write VT. Okay. So now we will see, we are actually supposed to, in today's lecture, we will see what is the operating point. Then we will learn how to plot the DC load line, and what is the biasing method. What is the biasing method? Now remember, throughout your electronics, you will always come across a word called as biasing. Biasing in the simplest form can be understand as connecting power supplies to the device. Now I have a MOSFET IC. Yeah, I have a MOSFET IC. Whenever I want to take it in use, I must apply power sources. You have mobile phone with it, right? You must charge your mobile phone if you want to operate it, right? Similarly, if any electronic component, if it want to be worked, if we want it to be working in the circuit, it must be supplied with the proper voltages. So applying voltages to the component or device is the basic meaning of biasing. What is biasing? In the simplest term, I can say biasing means voltages, applying voltages or potential difference across these devices so that it will be active, so that it will start working. Okay, so this is the simplest meaning of biasing. Now, how shall we bias MOSFET? If I want to use MOSFET to be used, how shall I bias? Now we have already learned that we have to make VGS positive, that is gate to shall be made positive with respect to source, and drain shall also be made positive with respect to source. This we have already seen. So that was the simplest form of biasing. Now when we are using two batteries in the circuit, we are using we are applying VGS. Okay, we are applying VGS and we are applying VDS. Now let us talk about amplifier. I'll come back to both these terms. Let us talk about amplifier. Now you have studied BJT as an amplifier in your first year, right? So what is an amplifier? This is the symbol of amplifier. In electronics, if you want to represent amplifier, this is the symbol of amplifier. So amplifier is a device where you give a small signal and at its output, you get the enlarged signal. Remember, amplifier is increasing the signal level, or I will say the signal voltage. If I apply low level signal or low voltage signal, very small signal, then this amplifier will increase the magnitude of that signal. So I will get amplified signal. Remember, amplifier is not going to change the frequency of your signal. Suppose I am applying a 50 hertz, let's say 1 kilohertz signal here. So output shall also be of 1 kilohertz. So amplifier is not going to change the frequency. Frequency shall remain as it is. Only it should increase the magnitude of the applied signal. And this is what an amplifier. Now, when I want to use MOSFET as an amplifier, I must apply my signal to the gate. Okay, where shall I apply? Now, see, yesterday I told you how to draw the symbol of MOSFET. So this is the gate terminal. Okay, and this is broken terminus 1, 2, 3. Okay, sub terminal broken terminals are shown, which indicate enhancement MOSFET. There is gap between two, indicating insulated gate. Gate is insulated. Okay, right. So middle terminal and this terminal. This is your source, substrate, and this is the source, and they are connected together. And remaining terminal is drain. Now, when you have studied transistor and where you have studied three configuration: common base, common emitter, common collector. Similarly, MOSFET can also be used in common drain, common gate, and common source configuration. For amplification, we will use the configuration as common source. See, common drain or common collector, these are having other applications because they are having unit gain amplifier. Okay, so we don't use it as we do not use them as an amplifier. So when you apply gate signal, I must get the output signal. But can I apply the gate signal to this MOSFET? No, I must bias it, otherwise it will not come into work. Are you getting? If I want to use MOSFET as an amplifier, I must apply the signal to a properly biased MOSFET. Got it? Now in this figure, I have not connected any supply voltage here. Any supply voltage I have not connected. So I must apply proper signal. Now what will happen? Suppose I have applied gate signal here and I am providing some drain voltage, okay, some positive drain voltage, but VGS is not positive. So you know that I can't do this. Why? Because you have studied the transfer characteristics. And you know when you increase VGS, this MOSFET does not conduct unless and until the VGS reaches to VT. Are you getting? Unless and until the applied voltage at a MOSFET, it doesn't, if it does not exceed VT, then there will be no current flowing. In this region, suppose value of VT is 2 volt for a particular MOSFET. So when you are applying a signal, now let's look at our previous slide. Let's go back again. Why I cannot use this? I have applied a signal. Let's say signal is of 1 millivolt, 1 millivolt. And the threshold voltage for a MOSFET is, let's say, 2 volt. So in this case, because your input signal is very less than threshold voltage, there will be no flow of gate current. So is the signal able to make the MOSFET conducting? No, because signal is of very small, signal is having very less voltage and MOSFET threshold voltage is higher. So So in this region, if your signal, because when you are using MOSFET as an amplifier, your signal is of very low value. So that low value signal is not may not be able to exceed in the amplitude greater than VT. So that signal is not able to turn the MOSFET on. So what I need, that if I want to use MOSFET as an amplifier, I must bias it so that input voltage will be greater than threshold voltage. Then only that MOSFET will start conducting. You also know that there must be proper value of VDS also. Okay, there must be a proper value of VDS also. What is that value? See, if you want to use MOSFET as an amplifier, it must present in the saturation region. It must present in the saturation region where it is providing you the maximum current. That is why, because I want amplification, I want my signal to be amplified. So I need maximum current flowing through the load resistance. So which region provides you maximum region? Saturation region provides you maximum region. So if value of applied VDS is less than VDS sat, I will call this as VDS sat. So I am using a circuit, but if I am keeping the value of VDS less than VDS sat, the MOSFET will not provide, the current through the MOSFET is changing linearly and it is not providing me the maximum current. Remember, in saturation region, MOSFET act as a current source. What is the job of a current source? To provide a constant current, to provide the current. If I call it as a constant current source, it means it should provide the constant value of current. So when MOSFET remains in saturation region, it is provide you the maximum as well as constant current. And this current depends on input voltage, right? See, this is input voltage, VGS is 3 volt, I get this current. If I increase, I get larger current. If I still increase VGS, I get larger current. So who is controlling this drain current? VGS is controlling drain current. In short, I can say MOSFET act as voltage controlled current source. Why current source? Voltage current controlled current source. Current source means one which is providing constant current. So MOSFET is providing you constant current when it is present in the saturation region. And who is controlling this? VGS. So I can call it as voltage control current source. So I must ensure that my MOSFET, if I want to use it as an amplifier, it must be present in saturation region as well as the VGS applied shall be greater than threshold voltage. So which two condition I must remember? Please repeat. Please repeat. Which two condition I must remember if I want to use MOSFET as an amplifier? Anybody unmute yourself. Instead, I used to call your name and wait for you. Quickly, you must answer. This is not your first year. Now you are second year students. No? If you don't answer, it means you are not getting. Shruti Mandale. Yes, Shruti. Shruti is absent. Shrutika Dhore. Shrutika Dhore. Absent.
Yes, ma'am.
Shubham.
Yes, ma'am.
Okay. What are the two conditions I must remember if I want to use MOSFET as an amplifier? Just now I had told you the two conditions. Yes, Simarpreet. Shrutika, you are not paying attention. This means you are not paying attention. No, Samarpreet absent. Simarpreet absent. Saloni,
Present, ma'am.
what are the two conditions I must remember if I want to use MOSFET as an amplifier? Who is attending the lecture? Not by only logging in the meeting. Who is attending the lecture? Those can answer. Yes.
Amplifier increases the signal level of MOSFET, and MOSFET act as voltage control current source.
Okay. When I want to use MOSFET as an amplifier, what two things are must? In which region shall I use MOSFET for amplification?
Saturation region.
Saturation. Okay. Means what is the condition for VDS? It should be the value of applied VDS should be greater than VDS sat. And what is the condition for VGS?
It
What is
should be greater than threshold voltage.
it should be greater than threshold voltage. Very
Threshold.
good. Yeah, it should be greater than. So VDS should be greater than VDS sat. VDS should be greater than VDS sat. And see what is value of VDS sat? Actually, VDS sat is given by VGS minus VT. The applied gate to source voltage on the MOSFET minus threshold voltage of the MOSFET gives you value of VDS sat. Okay. So VDS shall be greater than VDS sat, and another condition, VGS shall be greater than threshold voltage. So now this curve I will be explaining you later when I will explain you MOSFET as a switch. Now how shall I achieve this? Okay, how shall I achieve this? I want let's say a MOSFET. I'll use a whiteboard. Okay, so now we have seen that if you want to use MOSFET as an amplifier, how we shall bias is. Okay, so you are keeping VGS positive. Sorry, VGS, you must make VGS positive. You shall apply you should make gate positive with respect to source and drain positive with respect to source. Source and substrate, they are of course connected. So this type of biasing you must provide. Now, in general, what happens? There are many methods by which you can bias the MOSFET. But keeping multiple batteries or number of power supply makes your circuit very lengthy and bulky. Okay. So if I want to provide good method of biasing, I will be reducing this number of sources. So one method that you are supposed to use is the biasing voltage divider bias method. Okay? Voltage divider bias method. There are many methods of biasing that you can use. Like one which is shown here. So in this method, what is done? External power supply. A gate resistance is connected here and external power supply is connected. See VGG. VDD. So you are applying VDD. So it will take care that VDS, the voltage between these two will be greater than saturation voltage, and you are connecting one more power supply here, VGG, that will keep your gate voltage always positive. Okay, this is one method, but in this method you see there are two voltage sources are involved, so which makes the circuit bulky. So what the general method which is preferred for MOSFET biasing is the voltage divider bias. It is same as what you have used in transistor. This is same as voltage divider bias method you have used in transistors, right, in first year. So similarly, this is a voltage divider biasing method. Now you are applying here only one source. Okay, only one source VDD is applied. So when you apply VDD, the current will flow to this path. Okay, current will flow. The drain current ID will also flow like this. Okay, and this current will develop some voltages. Now in this method, the voltage which is present or dropped across R2, that takes care that VGS will remain greater than VT in spite of any level of signal. When here signal comes, it becomes positive as well as negative. So even though the signal becomes negative, the voltage across this resistance will take care that VGS shall not fall. VGS will be greater than VT. VGS will always greater than VT. Okay, so in this method we are avoiding the number of batteries. Why this method is called as voltage divider bias method? Because you are connecting two resistances here, R1 and R2, which forms the voltage divider network. Everybody shall pay attention. I will ask you a question, that time you must able to answer. If you are not getting, you please let me know, I will repeat it. Okay, so this method is called as voltage divider bias method because you are using a voltage divider network. What is a voltage divider network? If this is voltage VDD present here, and if you are connecting number of resistances, so the whole voltage is dropped across all these series resistance. So some V1, V2 and V3. Whereas the current which is flowing, it is constant. So let us say the current which is flowing is ID. So in this, I have shown you. Okay, here I am applying VDD, let us say 5 volt, or let it be 10 volt. And let's say this resistance is 1K, this is also 1K, and this is also 1K. Okay, so it may be of different value, not for simplicity I'm explaining you one voltage divider network. So all these resistances are connected in series. So let's say the current which is flowing here is ID. So what is value of ID? How you will calculate ID? Yes, this is, see, same circuit I will draw like this. There is no difference. Plus minus, this is VDD 10 volt. Okay, so remember this is a complete circuit. This is your positive terminal of supply. This is your positive terminal of supply. Then this is your R1, R2 and R3. Okay, so start from this point, R1, R2, R3. So this is your positive terminal R1, R2, R3, and this is the ground. So this is the ground. So this terminal is further grounded. This voltage is voltage VDD is measured with respect to this ground. So don't worry that it looks, probably it may be looking something different as what you have studied in first year. So this is a complete circuit. Now let us calculate the current flowing through this path. Okay, can anybody tell me how much is current flowing through this path? How to calculate? Apply Kirchhoff's voltage law. Okay, apply Kirchhoff's voltage law. So what that law says, sum of voltages in a closed loop is equal to 0. So what is the first voltage? VDD. Start from VDD. Then I am moving along the direction of current. So I will take the sign of the voltage drop as minus. So what is voltage drop across this resistance? 1K. Let's say this is as R1. R1 into ID. Move further. What comes? Next resistance minus R2 into ID. Further minus R3 into ID equal to 0. Okay. So I can write as VDD equal to, take everything on the right hand side. Then I will take ID common. So it will become R1 plus R2 plus R3 into ID. Got it? Therefore, how you will find ID? ID is equal to VDD upon R1 plus R2 plus R3. Now you can substitute the values and you can get the current. So this way you can find the current in the voltage divider network. Come back to this slide. So you have connected this voltage divider network. Now it is having only two resistors. Are you getting? Everyone, unmute yourself and please tell me. Are you getting?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So I told you how to calculate current through a voltage divider. Very simple. Now such kind of voltage divider which is formed by using resistance R1 and R2 is used in MOSFET biasing. Okay, we will study only this method. And this is your enhancement MOSFET. We have shown symbol. Okay, drain resistance is connected at the drain, and this is the source resistance which is connected at the source. Now when you want to use MOSFET as an amplifier, you must apply the input signal at the gate. Okay, so this is gate terminal, and you have, this is your input signal which you will be applying to the gate. Now whenever you are applying any AC signal to the transistor, remember you have to give it through a capacitor. Can anybody tell me the reason for this? Can anybody tell me the reason for this? Why input shall be given through, why input shall be given through capacitor? As well as when you apply, when you want to take the output here, you will get the amplified output, right? So here also you connect one capacitor. Further, I will tell you that we will connect one capacitor here also. Okay. So remember, at this stage, you remember that when you want to apply signal, that AC signal, along with that AC signal, there may be some noise, or there may be some DC signals. Okay. So capacitor will pass only AC. What is the reactance of capacitor? Xc is equal to 1 upon 2 pi Fc. Okay. For DC signal, F is 0. For DC signal, frequency is 0. So what this reactance becomes? Equal to infinite. So if there are any DC conditions present inside, that will not enter in the circuit. And by this way, it will not disturb the previously present conditions in the circuit. Okay. Because with this circuit, now we will come to know that there are some values, DC levels of VGS, VDS, they are set, and signal will vary above and below these preset DC levels. So additional DC shall not enter. That is why you apply capacitor when you give input, And similarly, you apply capacitor while taking output, so that the DC conditions which are present in this circuit, that should not appear. If you remove this capacitor, probably you will get a signal like this, shifted upward, okay, because some DC is added. But if you put here a capacitor, you will get a proper signal without any shift. So that is why you must apply the signal. Understood? You must apply the capacitor. So now we will solve this circuit. Okay. So first of all, understand what is the operating point. Operating point. Everybody will pay attention. I will be every time asking you what is operating point. Okay. This operating point is also called as Q point. It is also called as silent point. Q point or silent point. Okay. Now I will define operating point. Everybody has to pay attention. Operating point is defined as zero signal value of VGS, VDS and ID. Now what you will say, madam, what is zero signal value? Zero signal means when there is no signal, no AC signal. What is zero signal? Zero signal means no AC signal. Zero signal means no AC signal. It means when there is no AC signal, whatever values of voltages and current present in the circuit, they are called as operating point. Understood? What is the operating point or Q point or silent point? Why it is called as silent? Because presence of AC is something noisy. So when there is no AC, the circuit is called as silent circuit. Means we call that condition as silent. The value of the voltages and current, so we call it as silent point also. Okay. So I'll read again, define operating point. Operating point are the zero signal value of voltages and current that exist in that circuit. Okay, means the value. Now which voltages appear here? Which are the voltages that are associated with this circuit? One is drain to source voltage. Now see, you have applied here VDD. You have applied VDD. There is a drain resistance, and between these 2 points where there is a drain terminal and source terminal, so in between two there is a voltage called as VDS, voltage between drain and source resistance, and I may call the voltage across this as VS. Okay. I may call this as VD. So the value, and again there is one more voltage between gate terminal and source terminal, to which we call VGS. So value of VGS, VDS and the current which is flowing, ID. These are called as operating point when there is no input signal. Means all those values are they AC or DC? Tell me now. These values are AC or DC? Yes. These values are AC value or DC value?
AC value.
AC.
No, beta. No, it's not AC.
DC value.
Because I am saying AC zero signal. I will repeat it. What is zero signal value or operating point? Operating point म्हणजे काय, की जेव्हा सर्किट मध्ये कुठलाही AC सिग्नल नाही, त्यावेळेस त्या सर्किट मध्ये जे DC व्होल्टेजेस आणि करंट एक्झिस्ट करतात त्याला ऑपरेटिंग पॉइंट म्हणतात. अंडरस्टूड? आय हॅव एक्सप्लेन यू इन मराठी. सिग्नल नसताना सर्किट मध्ये ज्या डीसी कंडिशन्स असतात त्याला ऑपरेटिंग पॉइंट म्हणतात. तर डीसी कंडिशन्स कुठल्या कुठल्या आहेत? VGS आहे, VDS आहे, ID आहे. So all these are the DC voltages or current. So I will say zero signal value of VGS, VDS and ID for a MOSFET is called as operating point for that MOSFET. Understood? लक्षात राहील? Any confusion? AC DC मध्ये काही confusion आहे? Zero signal value of जसं तुम्ही ट्रान्झिस्टर मध्ये if I ask you what is operating point, so you will say zero signal value of IC and VCE is the operating point. There may be zero signal value of VBE for the input. Okay, so operating point means value of the DC value of voltages and current that are present in that circuit. Permanent लक्षात ठेवा. Throughout your engineering, you must know what is operating point. Now, I'll draw here one graph. Okay. So on this axis, I am showing drain current, and here drain to source voltage. And you know, we can plot the characteristics, VI characteristics like this, and it appears like this. So for VGS equal to, let us say, 3 volt, I have drawn these characteristics. So now for any circuit, ID can have two value. One is maximum and one is minimum. Minimum can be 0, maximum can be that depends on the value of resistance that you are using. And similarly, VDS possible value are 0 and maximum. Now let us find what are these values. What I mean to say, that whatever is the value of operating point, whatever is the value of DC voltages and current, they will lie between two value of ID, that is 0 to maximum, and for VDS 0 to maximum. Now what I'll do, let us apply KVL in the output circuit. Okay. Apply KVL in the output. Now when we are doing DC analysis, okay, let's do DC analysis of this circuit. There are two types of analysis you can do. One is DC analysis, another is AC analysis. When you want to go for DC analysis, make sure that there are only DC conditions. So see, this battery is DC, so I will keep here. Now input signal is AC, and this is a capacitor which is passing the signal. So what I will do, I will remove this capacitor. For DC, what is the reactance offered by a capacitor? What for DC, आत्ताच सांगितलं मी. What is the reactance formula of capacitor?
1/2 pi FC.
Okay. For DC, what is the value of frequency? 0. DC is a strict signal, 0. So what that
0.
reactance? Good. What that reactance will become? Infinite. Means it will act like an open circuit. म्हणजे DC साठी has a capacitor, right? It will act like an open circuit. Okay. Similarly, this will act like a open circuit. Okay. Therefore, this capacitor will be no more there. लक्षात आलं? So you have to take this care when you are doing DC analysis. Remove this capacitor or open this capacitor. आता इथे काही नाही. Okay. Now what is left here? R1, R2, RD, RS, VDD. Now apply KCL. Kirchhoff's current law apply करूया. So start from this point. This is your output circuit and this is the output loop. Come on, tell me. Apply. Start from this point VDD. आत्ताच आपण मागे लिहिला होता ना तसंच. VDD. This is the direction of drain current, conventional drain current. So it will be minus ID into RD. Further, which voltage is there? VDS. Right? Here there is VDS voltage between these two terminals. So I will write it as minus VDS because I am moving from higher to lower. This is, I will also write the polarity. And further, what is there? ID into RS. Let's say the same current is flowing here. So this will be, actually that is ISRS, that is source current into this resistance. But source current and drain current are almost same. So I will write this as ID RS equal to 0. Got it? Got the equation? So from this, I can write, simply I have applied KVL from this point to this point. Let's call this as A and let's call this as B. So first voltage is VDD minus, I consider minus because I am moving along the direction of current. So minus ID RD is the next voltage drop, which is the further voltage drop VDS, which is present between drain and source. Further, the voltage drop present across RS, it is ID into RS. So from this equation, I can write the current directly. Tell me what is current. You can take ID common. Somebody please tell me what is value of ID. Take all this term on the right hand side. So ID is equal to VDD minus VDS. This VDD minus VDS divided by RD plus RS. So for this circuit, what is value of ID? Got it? How I have calculated this value of ID? Simply I have applied KVL in the output loop, return the equation, rearrange it, so it will become VDD minus VDS equal to IDRD plus IDRS. Why I have taken here also ID? Because IS and ID are almost same. Okay, so this is my equation. Got it? Now, when this ID can be maximum? When this ID can be maximum? या इक्वेशन मध्ये ID maximum कधी असते?
When RD and RS are maximum.
When ID and RD are maximum, these are the resistance. These are the resistance whose value we have to decide. Now there is VDD and VDS. Okay, so maximum, this numerator can be maximum when VDS equal to 0. बरोबर ना? जेव्हा हा numerator maximum voltage upon resistance म्हणजे current maximum. So now here it is VDD minus VDS. If VDS is 0,
ma'am, it is always positive.
what?
VDD minus VDS.
No, my question is, what is the when you can get ID equal to maximum? ID maximum कधी असेल? ID maximum possible value काय आहे ID ची? If VDS is 0, if you say VDD is 0, then whole ID will become 0. Numerator shall be maximum. Now when numerator can be maximum? When VDS equal to 0. So you can get ID max when VDS equal to 0. Okay. Now, if I write this equation in the form of VDS, okay, so what will be your VDS? VDS, same equation I am arranging it. VDS will be equal to VDD, I call that equation 1, VDD. So now I want this, so it will be VDD minus IDRD minus IDRS. Okay, so if I take ID common, I will write VDS is equal to VDD minus ID into bracket RD plus RS. Now, what is the maximum possible value of VDS? कधी मिळेल मला? Then I can get maximum value of VDS. I call it at VDS max. या सर्किट मध्ये, forget about others. Yes. When can I get VDS maximum? कधी?
0 volt.
काय? VDD? लक्षात ठेवा, if you make VDD 0, your circuit will be off. Circuit will not operate. हे याचा supply आहे. In this equation,
When ma'am ID is 0.
Very good, very good. Who is this? So I will get VDS max with if ID is 0. जर मी ID ला 0 put केलं, if I put ID 0, I will get VDS equal to VDD, and VDD is the maximum voltage. And in this equation, if I put VDS 0, I will get maximum ID. Have you got it? Why I am explaining you will now come to know. I will now share my book. हे लक्षात आलं तुमच्या? I will write here. ID, what I have done, I have simply applied KVL and I have arranged the equation in the form of ID and VDS. And now I wanted to know when my ID can become maximum and when my VDS can become maximum. So if I put VDS 0, I get ID max. If I put ID 0, I get VDS max. Now I will draw here a curve. Here only I will show. I will draw one graph here. So on this graph, I am showing ID and here I am showing VDS. You know what is value of ID max? Yeah, excess or maximum ID. I want to show maximum ID here. So what it will be? It will be VDD upon RD plus RS. Is it not? A maximum point माझा मी इथे दाखवला. ID max. काय ID max. And I want to show now VDS max. So हा आहे माझा VDS axis. So when I get maximum VDS, when my ID is 0, म्हणजे माझा point या axis वर येणार. So this is my VDS max. किती आहे VDS max ची value? VDD जेवढा supply voltage. So this is my VDS max point. This is my ID max point. So ID max point I get when VDS is 0. Yeah, point here. And I get VDS max when my ID is 0. Now suppose if I join these two lines, if I join these two lines, what I have shown the line is called as DC load line. या लाईनला काय म्हणतात? DC load line. Now what this DC load line is giving you, it is joining maximum value of ID and maximum value of VDS. Now you will come to know whichever circuit you will design and whatever value of ID and VDS you will get, that will be on this line, because we have drawn a line which is joining two maximum points. One is ID and another is VDD. So whatever is the value of ID and VDD that exist in this circuit will definitely lie on this line. Now you know, if I draw such output curve, if I draw output curve for MOSFET, it's something like this. Okay, and let us say I have drawn this for VGS is equal to, let's say, 2 volt. So this is our output characteristics. Okay. This is the output characteristics and DC load line. So the point of intersection of DC load line and output characteristics gives you the operating point, Q point. What is Q point now in terms of graph? The point where DC load line and characteristics intersect each other. म्हणजे this value of VDS and this value of ID is present in the circuit where you are keeping VGS equal to 2. Got my point? कुठल्याही सर्किट एकदा तुम्ही मॅक्झिमम आणि मिनिमम VDS आणि ID ची व्हॅल्यू काढली की जे पण सर्किट मध्ये ID VDS असणार ते या लिमिट मध्येच असणार. So you can plot the curve for them, and the curve where it intersect, that gives you the existing value of ID and VD, that is operating point of your circuit.
Ma'am, it is constant, Q point.
Hello, please repeat.
Ma'am, it is constant, the Q point is?
Q point is, you want to say Q point is constant? Yeah, Q point is what? Value of DC value of VGS and ID. VDS and ID. So it will be constant for a designed circuit. Once you decide what is the value of R1, R2, first you have to know what should be the operating point, then you design the circuit, then you get value of ID and VD, RD, R1, R2, RD, RS. Okay, so it will remain constant. But if you change the value of these components, then it will different. It will change. Got it? And now this is
Yes, ma'am.
operating point, as you have asked a very good question. Further, we will also talk now, there are some conditions which make that operating point varying. Like if there is temperature variation, but the MOSFET is a semiconductor device, na? So whenever there is temperature happens, the operating point try to shift, because the changes in the current and voltages happen. So operating point tends to shift. But if operating point changes, then your output also changes, which is not desired. So anyhow, we are providing these biasing methods. See, I came to on the same point with your question, that we are designing this circuit so that the operating point shall not change whatever is the condition. Okay, very nice question. If this operating point change, so whatever output you are getting, no, that will also shifted. तुम्हाला जे आउटपुट पाहिजे होतं ते सुद्धा चेंज होणार, कारण आउटपुट काय असतं, the AC output that varies above and below the existing DC voltages and currents. But if your existing DC voltage and current that is changing with your environmental condition, then your signal will also change, which is not required at all. Therefore, you are designing these biasing such that whatever will happen, but your operating point will remain same. Circuit ची ही जी action आहे ना, I will explain you. It's not the part of your syllabus, but I will explain you in the next lecture. की हे सर्किट कशी घेते की ऑपरेटिंग पॉइंट जेव्हा चेंज व्हायला जातो, हे सर्किट परत त्याला त्याच जागेवर आणतात, so that your output shall not change. Okay, so this is all about DC load line. Why this is called as DC load line? Yeah, I have written here ID equation. Okay, if I want to write this ID equation, C, which is your Y parameter, ID, which is your X parameter, VDS, I can write this ID as VDD upon RD plus RS minus 1 upon RS into VDS. Same. It's equation baga. Equation 1 je. Let's call this as equation 2, and I wrote it in more simplified form. What I have done only, I wrote this equation in the form of y equal to ID. ID is a y parameter, so I'll write y equal to, this is VDD upon RD plus RS. All these are constant. Your supply voltage is constant and your value of resistance will remain constant. So this is a constant term. So I will call it as C. Okay, and this is the slope that depends on the load. So this is, I will call this as M, and VDS is the X parameter. So I can write Y equal to MX plus C. Okay, Y equal to MX plus C, which gives you the equation of a straight line. So this is called as DC load line. Okay, and load line ka manta त्याला, because its slope depends on this RS, which is a load. Okay, so today we have completed how to bias MOSFET, what is operating point, DC analysis of this circuit, and the DC load line. In the next